Welcome to the Deep Dive. Today, we are really getting into the weeds on something fundamental, network management models and automation.
Yeah, it's a big one.
Absolutely. Our mission here is to go a bit deeper than just talking about, protocols and cables. We want to distill the core frameworks, the principles, the architectures that really govern how modern networks get monitored, maintained, and importantly, secured. It's about the operational strategy behind it all.
And it's so critical. I mean, think about it like this. Imagine driving your car, but with no dashboard.
Right. No speedo, no fuel gauge.
Exactly. You could drive, technically. But the second something goes wrong, engine light comes on, you're low on fuel, trying to figure out what the problem is, well, it becomes incredibly slow and difficult.
And in networking, that kind of delay isn't just inconvenient, it costs money. It can damage trust with customers.
Absolutely. That dashboard gives you the visibility you need.
Which ties into the whole life cycle, doesn't it?
Yeah.
We often talk about the network development life cycle, the NDLC. You've got analysis, design, simulation, implementation. Maybe that takes a few months.
Could you? Yeah.
But that final phase, monitoring and management, that goes on for years, sometimes decades, until that network's finally switched off.
And it's usually the most expensive phase, too, over its lifetime. Network management, if we define it broadly, it covers, well, all the activities, methods, procedures, tools, everything related to running the network day to day. Administration, maintenance, provisioning.
Making sure it runs efficiently, but also, and this is key, in line with what the business actually needs.
Exactly. Your technical decisions, they're always tied to business goals. Maybe it's hitting uptime targets, or maybe it's just sticking to a really tight budget.
Okay, so let's unpack those goals then.
Okay.
Because there's been a huge philosophical shift, hasn't there? Moving away from just reacting when something breaks.
Oh, completely. From reactive to proactive.
Yeah, the old way was, user calls up, hey, my internet's down.
Right. The help desk nightmare.
The gold standard today is totally different. You, the network manager, you spot the problem, you maybe even fix it automatically, and then you tell the user, yeah, we saw a brief issue there a few minutes ago, all sorted now.
That's the dream. And that dream, that proactive capability, it hinges entirely on continuous monitoring. You can't be proactive if you're blind.
So you're not just waiting for the red light to flash.
No way. You're constantly checking key indicators on, well, ideally every managed device. How's the CPU doing? Memory usage? Is the disk filling up?
Which leads to what you call proactive maintenance.
Precisely. If your monitoring system predicts, say, a server's storage is going to be full in 90 days,
You order the new drive now.
you order it today, not 91 days from now when everything grinds to a halt because the logs filled up.
And it's not just about the health of the boxes themselves, is it? It's also about what's flowing through them, the traffic.
Oh, absolutely. You need that deep visibility to see what's normal and, crucially, what's not. Imagine you suddenly see a huge spike in, I don't know, BitTorrent traffic on the corporate network.
Yep, that shouldn't be there.
Or maybe a massive data transfer starting at 3 a.m. going out to a weird IP address. That's not just a performance blip. That could be a sign of a security breach. Or maybe just policy misuse. But either way, the manager needs to know immediately.
I see. And that visibility, that data, it's also how you prove you're meeting your promises, right? Your SLAs.
Your service level agreements, exactly. If the business promises, say, latency to a cloud app won't go above 100 milliseconds.
Your management system needs to flag it the moment it starts creeping up to 200, 300 milliseconds consistently.
And that data isn't just for tweaking performance. It's often required for compliance, for audits. You need proof. You need a list of devices, their status, their configurations, hard evidence.
Okay, so the need is clear. The shift to proactive is the goal. We know the objectives. Let's talk structure. How do we organize all this? The foundational blueprint, really, was the OSI management model, wasn't it?
It was. It's, well, quite comprehensive, maybe a bit complex for some tastes, but it gave us the terminology, the basic concepts we still build on today.
Right. And it breaks management down into 4 parts: organizational, information, communication, and functional.
That's the one. Let's focus on the organizational model first, because it defines who's who in the zoo. Who are the players?
Okay.
So at the very bottom, you have your managed elements. These are the actual devices, your switches, routers, servers, firewalls, whatever.
Things doing the work.
Exactly.
Yeah.
Now, running on those elements, you typically have an agent. That's a little bit of software, basically, collecting data locally on that device.
Got it.
Then you have the manager. This is usually an application sitting on a central computer, a network management station, or NMS. The manager talks to the agents, pulls the data, processes it, displays it.
And the specific pieces of data,
Huh.
like how much bandwidth is going through port 3
Mm-hmm.
or the CPU temperature, those are the managed objects.
Spot on. Those are the individual data points the manager cares about. And importantly, we also have to remember the unmanaged elements.
Ah, yes, the ghosts in the machine.
Kind of devices that just don't support the management protocol you're using. Maybe it's a really old switch or something simple like a passive media converter. It's on the network, but your manager just can't see it or talk to it.
Right. Okay. So that's the basic setup. How does this scale up for bigger networks?
Good question. For small setups, the two-tier model is common. One manager talks directly to all the agents. Simple.
But for a big company, maybe with offices all over the place.
Then you need the three-tier model. This is where you introduce a middle layer.
Okay, explain that. These middle manager.
Right, these middle layer systems, they kind of wear two hats. To the devices in their local site, say a branch office, they act as the manager, they collect all the data locally, but then they turn around and act as an agent to the top-level manager back at headquarters. They summarize the data, maybe filter it, and send the important stuff upwards.
I see. So it distributes the load and helps organize things regionally.
Exactly. And for the really top-level view, for the executives maybe, you might have what's called a manager of managers, or MOM.
A mom.
Oh.
Okay. What does that do differently?
The mom isn't usually interested in the nitty-gritty, like router 7 CPU load. It wants the big picture, the aggregates. What's the overall network reliability in Europe this quarter? Are we sticking to the IT budget globally? What are the major capacity trends looking like for next year?
What's more strategic, less tactical?
Precisely. It provides that high-level business dashboard. There's also a peer model for redundancy or merging networks, but the tiered approach is more common for scaling.
All right. Now, this next bit you said is critical. The FCAPS model. You said this is something everyone in networking should basically memorize.
I really believe so, yes. FCAPS defines the core functions or activities that network management systems perform, regardless of the organizational structure. It stands for fault, configuration, accounting, performance, and security.
Okay, let's break those down. F and C first. Fault and configuration.
Yeah, these are the real workhorses, especially in day-to-day operations.
Okay.
Fault management is all about finding problems, detecting them, figuring out where they are, isolation, fixing them, correction, and keeping records, often using trouble tickets. Anything from a cut cable to a software bug.
And configuration management.
That's about managing the devices themselves, keeping an inventory, tracking every change made, backing up configuration so you can restore them, setting up new devices, taking old ones offline cleanly. Consistency is key here.
And, it strikes me that in today's world, especially with automation coming in, fault and configuration are getting really tightly linked.
Absolutely. You see that all the time. A fault is detected, maybe a link goes down. The system automatically diagnoses it and then triggers a configuration change to fix it, like rerouting traffic around the problem.
So automation really targets these two, F and C, because they're often repetitive, predictable tasks.
Exactly. They lend themselves well to scripting and automated workflows, which then leaves the other three, A, P, and S.
Accounting, performance, and security. These feel more strategic.
I'd say so. Accounting management is about tracking resource usage. Who used how much bandwidth? For how long? Maybe for billing customers or just for internal chargebacks between departments. Show me the usage.
Right, and performance management.
That's the continuous monitoring we talked about earlier, but focused on optimization. Watching link utilization, error rates, application response times. The goal here is to maintain quality of service and also to gather data to plan for future upgrades. Do we need more bandwidth here? Is this router becoming a bottleneck?
Okay. And finally, security management.
This is specifically about securing the network resources and the management system itself, controlling who can log in, authentication, what they're allowed to do, authorization, and keeping logs of security-related events, auditing, detecting and blocking unauthorized access or configuration changes.
It's interesting because, like you said, F and C are becoming heavily automated, but A, P, and S, they still require a lot of human judgment, analysis, and strategic thinking.
That's a very good point. A machine can reroute traffic around a fault pretty easily, but it takes a human manager to analyze performance trends over 6 months and justify spending millions on a network upgrade, or to design a complex new security policy based on changing business needs.
Which sort of leads us nicely into thinking about bigger frameworks, right? Especially for huge organizations like telcos. You mentioned the TMN model.
Yes, the Telecommunications Management Network from the ITUT. It's specifically designed for large service providers and organizes management into functional layers, often shown as a pyramid. It provides a more structured, hierarchical view compared to just FCAPS.
Okay, so layers, like the OSI network model, but for management.
Kind of, yeah. At the very bottom, you have the Network Element Layer, NEL. Those are the physical devices, again, the routers, switches, etc.
Right.
Just above that is the Element Management Layer, EML. This layer deals with managing specific types or brands of devices. It often handles vendor-specific functions, collects detailed alarms from those devices, manages backups for them. Think of it as the specialist for a particular technology.
Okay, so device-specific management, then what?
Then you broaden the view with the Network Management Layer, NML. This layer looks at the network as a whole across different types of devices. It's responsible for things like end-to-end provisioning, overall network optimization, coordinating configuration changes that affect multiple devices or domains.
So NML is the network-wide view,
Right.
but you said TMN has higher layers too.
It does, and this is where it gets really interesting and ties back to the business. Above NML is the Service Management Layer, SML.
Service management.
This layer focuses entirely on the services being delivered to the customer, not just the underlying network bits. It monitors things the customer actually perceives, like latency, jitter, connection uptime. Is the video call smooth? Is the website responsive? It manages SLAs from the customer's perspective.
So it translates network performance into customer experience.
Precisely. And right at the very top, the peak of the pyramid, is the Business Management Layer, BML.
BML. This sounds like the executive suite.
Pretty much. This layer deals with the overall business strategy, budgeting, long-term planning, negotiating with other carriers, deciding which new services to invest in based on market trends. It's completely strategic.
And the key insight is that those lower layers, NML, EML, and even SML, they're all implementing the FCAPS functions within their specific scope.
Exactly. FCAPS provides the functional building blocks that operate within each TMN layer.
Okay, that makes sense. TMN for telcos. What about general IT? Is there a similar framework?
Well, probably the most widely adopted framework in general IP service management is ITIL, the Information Technology Infrastructure Library.
ITIL. I've definitely heard of that. It's more about process, right? Best practices.
Exactly. While TMN gives you a structural hierarchy, ITIL gives you a service lifecycle. It focuses on how work gets done, the flow of activities to deliver and manage IT services effectively. It's very process-oriented.
And it has stages.
Yes, typically 5 core stages in the life cycle. It starts with service strategy.
Okay, strategy. So like the BML and TMN, high-level planning.
Similar, yes. Thinking about what services the business needs, market analysis, financial management for IT services, should we offer a new cloud service, how do we support a merger IT-wise?
Then after strategy comes.
Service design. This is where you take the strategy and turn it into a plan. You design the service, the architecture, the management systems needed, and importantly, you define the SLAs and how you'll manage risk. It's the detailed blueprint.
Makes sense. Design follows strategy. Then you build it.
Pretty much. That's service transition. This stage covers everything needed to build, test, and deploy the new or changed service into the live environment. Change management is huge here, making sure the deployment doesn't break anything else. Testing, release management, knowledge transfer.
Okay, so it's live. Then you just run it.
That's service operation. This is the day-to-day. Running the services, monitoring them, making sure they meet the agreed SLAs, handling user requests, fixing incidents when they happen. This is where FCAPS lives day-to-day in an ITIL world.
And the final stage.
Continual service improvement, or CSI. This is crucial. ITIL emphasizes that you should always be looking for ways to make the services and the processes better, more efficient, more cost-effective. You use the data from service operation to feed back into the strategy and design stages. It's a cycle.
Right, so it's not just set it and forget it. You're always looking to improve. That seems like a really solid approach for managing complex IT.
It is. It provides a common language and set of practices that many organizations find very valuable.
Okay, so we have these models, OSI, FCKPS, TMN, ITIL. How do we actually talk to the devices? What are the tools?
Well, the protocol that really won out for basic network management, despite the complexity of OSI, is SNMP Simple Network Management Protocol. It's part of the IETF model, which is more of a practical, protocol-focused approach than a grand architectural model like OSI or TMN.
SNMP.
Oh.
Right. So the manager uses SNMP to pull the agents for those managed objects we talked about.
Exactly. It's relatively simple, widely supported, hence the name. It allows the manager to get data like interface counters and sometimes set data like changing a device's contact info. And agents can also send alerts called traps back to the manager if something important happens.
But SNMP is just the communication, right? The real revolution lately seems to be network automation. Why is that suddenly such a huge deal?
Scale, complexity, and speed. Think about modern networks, thousands, maybe tens of thousands of devices, physical and virtual. Trying to configure all of that manually, logging into each box via command line or a web interface.
Sounds exhausting.
It is exhausting, and it's incredibly slow, really expensive in terms of engineer time, and worst of all, it's massively prone to human error. One typo in a critical command.
And you could bring down a whole service. Or worse.
Exactly. Automation is about taking those repetitive, error-prone manual tasks and letting software handle them.
So network automation is kind of an umbrella term.
It is. It covers everything from simple scripts to sophisticated orchestration systems. But a key architectural shift enabling much of this is software-defined networking, or SDN.
SDN. Separating the control plane from the data plane.
That's the core idea, yes.
Yeah.
Taking the brains of the network, the decision-making part about where traffic should go, and centralizing it, rather than having every single router figure things out independently.
And there are different ways to do that centralization, aren't there? It's not all or nothing.
Correct. We started with the traditional distributed model where every device has its own control plane. That's still common. Then you have approaches like the augmented model. Here, you still have the distributed control plane running on the devices, but a central SDN controller uses an API like OpenFlow or others to kind of nudge the devices, maybe install some specific rules or slightly modify behavior without taking full control.
So the controller assists the existing system.
Right. Then there's the hybrid model, often seen during transitions. Maybe the standard routing protocols handle the basic traffic flow, but the central controller manages specific policies or new services or exceptions to the normal rules.
A mix of both worlds.
And finally, the most radical approach is the replace model. Here, the central controller completely takes over. The devices become simple forwarding engines, and all the intelligence moves to that centralized controller.
That sounds powerful, but maybe complex to implement.
It can be, but it offers incredible flexibility and central visibility. And this centralization paves the way for the next big idea, intent-based networking, or IBN.
IBN. This feels like the futuristic part.
It's definitely the direction things are heading. With traditional automation, you still often tell the system how to do something. Configure VLAN 10 on switch A, port 5. With IBN, you tell the system what you want to achieve the intent.
So instead of giving step-by-step instructions,
You just state the goal. For example, I need a secure, high-bandwidth connection between Application Server X and Data Center 1 and the Marketing Department VLAN in the London office, with less than 50 meters latency.
and the IBN system figures out how to make that happen across all the different routers, switches, firewalls involved.
That's the promise. The IBN system translates your business intent into the necessary network configurations, pushes those configurations out, verifies that the intent has been met, the translation activation assurance loop, and then continuously monitors to make sure the network stays compliant with that intent.
Wow, that's a huge leap from typing commands into a CLI.
It absolutely is. Think of the benefits. It drastically reduces the manual effort and the chance of errors. It speeds up deploying new applications and services from weeks or months down to potentially minutes
And it frees up the network engineers.
to focus on higher-level tasks. Instead of being bogged down in repetitive configuration, they can focus on architecture, design, security strategy, capacity planning, things that add more strategic value.
Okay, so that's quite a journey we've taken. We started with the basic building blocks, the OSI organizational model, the crucial FCAPS functions. We looked at how frameworks like TMN and ITIL provide structure and process, especially for larger orgs. And we've ended up with automation, SDN, and IBN fundamentally changing how the work gets done.
And it's important to see how they all connect. Automation, SDN, IBN, they don't throw away the old models. They build upon them. An automated system still needs to understand the goals defined by FCAPS. It
Yes.
still needs to perform fault management, configuration management, performance monitoring, even if it does it automatically.
Right. The what remains important even if the how changes
It's
dramatically.
exactly, the principles persist.
Which brings us back, interestingly, to those top layers we talked about, the business management layer in TMN, service strategy in ITIL. If the machines are increasingly handling the tactical stuff down in the NML and EML, the FNC of FCAPS,
Then the human role inevitably shifts upwards. It has to.
less time fixing the engine, more time designing the car and planning the journey.
That's a perfect analogy. The focus shifts from reactive troubleshooting and manual configuration to proactive design, strategic planning, and ensuring the network truly supports the business's goals.
So maybe the final thought for you, our listener, is this. As automation takes over more and more of the hands-on configuration and fault remediation, how do we, as network professionals, ensure that the complex logic driving these automated systems stays perfectly aligned with the high-level business strategy?
Mhm. If the machine handles the C and the F, how do we guarantee it's always working towards the goals set by the BML or service strategy? That demands a deep understanding of both the technology and the business. The future isn't about knowing the syntax of a command, it's about defining the strategy the commands need to execute.